right, practice final exam. Problem 1, part D. We want to evaluate this indefinite integral, and probably one way that you can see to do it is to use partial fraction decomposition. By all means, you can try that method, but I'm going to go a slightly different route. And so what I'm going to do is actually a trigonometric substitution, because I see that I have this x squared plus 1 to a power, that sort of term. So that leads me to the trigonometric substitution x equals tangent theta. And so I'll just calculate dx real quick. So this is going to be secant squared theta d theta. And then also what I want to do is just kind of simplify this expression here. So x squared plus 1, let's deal with that part first. So x squared plus 1 is tangent squared plus 1. We know from our Pythagorean identity this is secant squared theta, and then we're squaring that. So this denominator is in fact secant to the power 4. Okay, so now let's put everything together in the integral. So our integral is going to be dx, so dx is secant squared theta d theta divided by, in the denominator we have secant to the power 4 theta. So of course 2 of our powers of secant are going to cancel. We'll be left with a secant squared in the denominator. Okay, but secant squared in the denominator is the same as cosine squared in the numerator. Okay, and we know how to integrate cosine squared. We talked about it in part B of problem 1. So you can watch that video again if you want to, but we'll do it right now. So either way, we know that we can use the half angle identity to rewrite cosine squared theta as 1/2 1 plus cosine 2 theta d theta. All right. And so now we have that this is equal to 1/2. I can pull my constant multiple out, not an issue, doesn't depend on theta. Then I need to integrate 1. I need to integrate cosine of 2 theta, so this is 1/2 sine 2 theta. I get a constant plus c, but I'm not in my original variable. I need to end up in x. Okay, and so I need to end up in x, so I'm going to have to draw some kind of triangle now. So let's see how we do this. So we knew from the beginning, so this is a right triangle, contrary to how poorly it's drawn. We knew from the beginning that x was equal to tangent of theta, right? So let's call this angle theta. And then what is tangent? Tangent is the opposite over the adjacent. So if I make this side x and this side 1, then the ratio of my sides is x, right? The opposite over the adjacent, it's equal to x. So then x equals tangent theta. Perfect. Okay, but we also have this other side that we'll want to evaluate at some point. So this side is going to be given by square root of 1 plus x squared. Okay. And so now we need to figure out what sine of 2 theta is equal to. So I'll simplify all this stuff in red down here, and then we'll just go ahead and plug it in at the end. So we know that sine 2 theta is equal to 2 sine theta cosine theta. And so the reason that I need to use that is because this picture is only good for the angle theta. It's not good for the angle 2 theta. But either way, so this 2 is obviously going to cancel with this 1/2, so I really won't worry about that at all. But either way, let's just write down what sine theta is, and let's write down what cosine theta is, and then we'll go ahead and put everything back into our formula. All right, so sine theta is opposite over hypotenuse, so this is x over square root of 1 plus x squared. And then cosine is adjacent over hypotenuse, so this is 1 over square root of 1 plus x squared. Okay. So that does it for figuring out everything from our triangle. And so now we just need to put everything back in its place. All right, so we have 1/2. So we already know that theta is going to be equal to arctangent because of this relationship x equals arctangent of theta. So this is going to be, I'll say 1/2 arctangent of x. And then we have plus. All right, so there was a 1/2 from here, there was a 1/2 from here, and then there was a 2 from here. So 1 factor of a half and 1 factor of 2 are going to cancel. We're still left with a factor of 1/2, fine. So we have 1/2, and I'll just write it like this first, sine theta cosine theta plus c. And then we'll replace our sine theta and our cosine theta with our expressions here. So this is going to be 1/2 arctangent plus sine theta is x over that stuff. Cosine theta is 1 over that stuff. So it's going to turn into x over 2. And then if you think about it, I have something that's positive, certainly 1 plus x squared. I have the square root of it, and I'm squaring it, right? So this is going to turn into 1 plus x squared in the denominator plus c. And so that's it. All right. Hope you enjoyed.